foodies, welcome back to Food Edge, and today in this video we are going to discuss a very important topic in food technology, and that is food spoilage. So generally food spoilage is nothing but the deterioration in the quality of food, and this deterioration may be due to the changes in its physical, chemical, nutritional or functional properties. So let's get into the topic. Generally, the foods are classified based on its shelf life extendability as perishable foods, semi-perishable foods, and non-perishable foods or stable foods. So these perishable foods generally have shelf life from few days to few weeks without any use of preservatives. So these preservatives may be natural or chemical, and also the preservation techniques like the non-thermal techniques or also the thermal techniques. So the examples of these perishable foods are milk, dairy products, meat, poultry, egg and seafood. So all these products without proper refrigeration will get spoiled easily. So this refrigeration technique is also a preservation technique. So the semi-perishable foods generally have long shelf life, about 6 months, under proper storage conditions. And the examples for semi-perishable foods are vegetables, fruits, cheese, and potatoes. So moving on to the next is the non-perishable or stable foods. So they generally have indefinite shelf life that may be around 9 months or even more than that, that is more than a year. So under proper storage conditions. So generally this proper storage conditions means either the airtight condition or the vacuum packaging or the modified atmospheric packaging depending upon the type of the product stored. So the examples are dry beans, nuts, flour, sugar, canned fruits, mayonnaise and peanut butter. Also the cereals and pulses comes under this category. So moving on to the next, what is food spoilage? So the process by which the food becomes unfit for human consumption, either by the activity of bacteria, fungi, molds, or enzymatic reactions, or due to insect infestation, or any other chemical or physical changes, we call that food is to be spoiled. So what are the common causes? So inadequate storage temperatures, prolonged storage times, improper ventilation, cross-contamination, excessive delays between receiving and storing the product, and also due to the activity of enzymes, microbes, and other chemical reactions. So, what are the spoilage signs that we can see in the food that has been deteriorated in its quality? So, I have listed the 4 common signs, that is the off flavor, or the off odor, the sliminess, the discoloration and souring. So the off odor is generally caused due to the breakdown of proteins, and this breakdown may be due to putrefaction, or also there is another phenomenon called the proteolysis, which we will see in detail. And one example for this off odor or the foul smelling products are the rotten egg smell. And next is sliminess. This denotes the formation of slime layer on the product surface, and this is due to the accumulation of the microbial cells on the surface of the product, mainly due to tissue degradation happening within the product. So discoloration or the depigmentation of the product takes place due to the effect of temperature or any other external factors, and this may be mainly due we can see this type of problems in the mold growth on bread, or blue and green mold on citrus fruits and cheese. Next is souring, and this is commonly caused due to the production of acid, and we can see mainly in the dairy products. So the example is sour milk, and this sour milk is caused due to the production of lactic acid. So moving on to the next, what are the factors affecting these spoilage? So the factors include physical, microbial and chemical. The physical factors include moisture content, temperature, glass transition temperature, crystal growth and crystallization. Whereas the microbial factors include the development or the growth of molds, yeast and bacteria. And the chemical factors include the chemical factors include oxidation, proteolysis, putrefaction, Maillard reaction, hydrolytic rancidity and light-induced reactions. So let us discuss in detail about all these factors in the upcoming slides. So moving on to the first is the physical spoilage, and we saw moisture, and generally to note a point, moisture and temperature are like they are the key indicators for the for maintaining the quality of any product. And so let us see how these affects the quality of products. So generally, high moisture foods are easily perishable due to their high water activity, and generally foods having water activity greater than 0.91 are highly susceptible to microbial growth. So moving on to the next is the temperature. Temperature plays a very important role in the spoilage of fruits and vegetables and meat products. So the significant factor for spoilage of fruits and vegetables is temperature. Why? Because increased temperature, that is generally above 30 degrees Celsius, causes increase in ethylene production. So this ethylene is one of the important plant hormone that causes ripening of fruits or vegetables in a plant. So when this ethylene is produced more, the ripening happens very fast. That is, the product gets overripe very soon, and due to this, the product reaches quick senescence. So senescence is deterioration in the quality of food, which is simultaneously accompanied by aging. But due to high ethylene production, the senescence is achieved quickly than its normal timing. So after harvest, the fruits and vegetables has to be stored between 15 to 30 degrees Celsius. That is, this is the optimum temperature, and it can be kept for few days, and it is generally said to be safe. So other temperature related issues are the chilling injury and freezing injury. So these two phenomena are interrelated to each other. That is, every fruit and vegetable has its own freezing point. So every fruits and vegetables has its own freezing point, and when these fruits and vegetables are held above their freezing temperature but below 15 degrees Celsius, this product undergoes chilling injury. Whereas when the fruits and vegetables are held below the freezing temperature, then they undergo freezing injury. So what is that is, the fruit or vegetable can be held at their freezing temperatures, or the temperature may vary in a negligible quantity. But when there is a drastic change of the storage temperature and the actual freezing temperature of the product, then these injuries takes place in the product. So moving on to the next is the heat injury. So exposure to direct sunlight or to excessively high temperatures causes this type of injury in fruits and vegetables. So moving on to meat. Meat is generally safe at 0 degree to 10 degrees Celsius, whereas the high temperature causes the growth of microbes and also causing depigmentation, that is the pigment oxidation, resulting in off colors and deterioration of other meat properties. So this is what we discussed about meat. And moving on to the next is the glass transition temperature. So this glass transition temperature may be a new factor that you might hear. So let's discuss in detail about this temperature. So this glass transition temperature is a key factor affecting cereals and high protein products, hard candy and milk powders, etc. So what is this glass transition temperature? So I'll tell you in detail. Generally, foods that are a glassy amorphous state, when they are maintained below the glass transition temperature, they remain a glassy amorphous state. That is, every product, like how fruits and vegetables have their own freezing point, similarly, every products, that is the cereals or high protein products, they have their own glass transition temperature. And when this product is maintained below their glass transition temperature, they usually stay at the glassy amorphous state. Okay, but when heat is applied to this glassy material, the temperature increases above the product's glass transition temperature, leading to a phase change. So generally, this glass transition temperature is the temperature required to change the phase of any material, any food material, either from glassy to rubbery or rubbery to glassy. So when the generally when the product has its temperature below its actual glass transition temperature, the product remains in a glassy state. But when temperature increases either due to heating or any other external factors, or when water is added to this glassy system, it converts to a rubbery system. And the vice versa of this reaction is the conversion from rubbery to glassy. That is, the water has to be removed either by dehydration or drying, and the temperature has to be decreased either by cooling or freezing. So this process of phase conversion is assisted by the glass transition temperature, or it purely depends upon the glass transition temperature. So okay, this is generally a process. How this process affects the quality of food. So when the product is converted from a glassy material to rubbery material, water is added. So when water is added, the water activity automatically increases, thus reducing its shelf life, leading to microbial growth. So when it is converted from a rubbery to glassy material, the temperature decreases either by cooling or freezing methods are used, and this cooling or freezing may produce uneven sized crystals or large sized crystals in the product, leading to the textural loss. So let us see in the next slide how crystallization affects the quality of a product. And before moving to crystallization, there is one other point to note here. The glass transition temperature is inversely proportional to the water activity of the product. So then again, the next point is crystallization occurs during the glass transition process. So let us see how crystallization and crystal growth affects the product quality. So foods which undergo slow or multiple freezing suffer severely due to the crystal growth. So this is because of the increase in crystal size during slow freezing process, and which this increased crystal size generally affects the cellular structure of the food, which leads to the textural loss of the product. So example of this process is aged cheddar cheese, where the calcium lactate crystals formed on the surface are confused with mold formation, and hence the product gets rejected in the market. And one other factor that affects, one other crystallization factor which affects the product quality is the ice cream taste, which may go sour due to the increase in crystal size. And this increased crystal size is mainly due to the continuous freeze and thaw cycles during storage. This freeze-thaw cycle is nothing but freezing is reducing the temperature of the product to its freezing temperature, whereas thawing is like increasing the temperature to the room temperature. So when the product is kept at a freezer and again it is taken out, again it is kept in the freezer. So when there is a continuous change in the temperature of the product, there will be the formation of large crystals, which leads to the coarse taste of the ice cream. And one other factor of problem is the sandy taste caused in ice cream. And this sandy taste is mainly due to the crystallization of lactose. So we'll move on to the next. It is the microbial spoilage. So the presence of moisture is the key factor for the growth of microorganisms, and the water activity has to be greater than 0.91 to facilitate easy growing of bacteria and other organisms. So this growth may be controlled by lowering the water activity, either by adding solutes such as sugar, glycerol, and salt, or by removing water through dehydration, drying, or other techniques. So the spoilage of that is the action of microorganism is more during log, that is the log phase is the growth phase, and stationary phase is where they feed on the nutrients of the product. So during the log and stationary phase, the spoilage occurring in the food is generally high. And examples of the organisms causing microbial spoilage, that is, there are only two examples listed here, just to know. We'll see in detail when we discuss microbiology section. So Clostridium botulinum, it is the most deadly organism, where it causes botulism in human beings, and they are spore forming bacteria, and they also produce toxins. So Clostridium botulinum is generally found in meat and poultry. It affects the quality of meat and poultry. And Bacillus cereus affects the quality of milk and cream by the production of toxins in the product. And this toxin production leads to food poisoning for the person consuming it. Therefore, it results in the causing of foodborne illness to the person. And next, we'll move on to fungi, yeast, and molds. These organisms generally can also grow in high acidic environment, and the pH range for yeast growth is 3.5 to 4.5, And for moles, it is 3.5 to 8. That is, they can grow from acidic to even in the alkaline medium also. So the low pH for fruits are unfavorable for the growth of bacteria, but yeast and mold can grow and cause spoilage in the fruits. So if you guys remember, we saw that in the spoilage signs, we saw discoloration, and that discoloration we saw the blue and green mold formation on citrus fruits, and why that is the reason it is mentioned here that the low pH is generally not advisable for the bacterial growth, but it is favorable for the growth of yeast and molds. So moving on to the next, yeast generally causes fermentation in the fruits, and this is done by breaking down sugars into alcohol and carbon dioxide. So this production of alcohol and carbon dioxide in fruits also causes the off flavor or off taste to the product. So the amount of water available is a critical factor for the growth of fungi. So yeasts are unable to grow at water activity less than 0.9, whereas molds are unable to grow at a water activity less than 0.8. So we will discuss about the examples of these yeast and molds that causes foodborne diseases. The mycotoxins produced by molds such as Aspergillus, Penicillium, and Fusarium that is commonly seen in cereals, legumes, processed flour, and smoked dried fish, and in dried meats causes foodborne illness when consumed. So next, so here we saw the molds, and that is the Aspergillus, Penicillium, and Fusarium. And next we'll see the yeasts, that is Zygosaccharomyces and Saccharomyces. So this Zygosaccharomyces is one specialized category where it can affect very low water activity products also, like the honey, dried fruits, jam, and soy sauce. Whereas the Saccharomyces will affect the alcoholic and other beverages like the wines and other alcoholic beverages. And they generally produce gasiness, turbidity, and off flavors due to the formation of hydrogen sulfide and acetic acid. So we'll move on to the next. Here are the minimum water activity that are required for the growth of the organisms. And for bacteria, minimum 0.91 is required, and for yeast 0.88, and there we saw 0.9. So that is the round off value, and here's the actual value. And for moles, it is 0.80. For halophilic organisms, it is 0.75. For xerophilic organisms, it is 0.65, and for osmophilic organisms, it is 0.60. So halophiles are nothing but they grow very well in high concentration of salts, whereas xerophiles, they require very low water content for their growth, or they can grow without water also. And osmophiles generally include, that is, they grow in the high concentration of osmotic solutions, that is the sugar. So that is given in the next coming lines. So we'll move on to the next slide. Next is the chemical spoilage happening in the food, and the factors responsible are the oxidation, proteolysis, putrefaction, etc. So let's discuss in detail about every process. So oxidation, generally it is a very common factor in fats and oils, where you can see it causes oxidative rancidity, and this oxidative rancidity is one of the important factor for causing off flavor and off taste in unsaturated fats and oils, which leads to its quality deterioration. And this off flavor or off taste is produced when this unsaturated fat comes in contact with oxygen. It forms peroxides, and when these peroxides are again reacted, they form hydroperoxides and products of hydroperoxides, that's the carbonyl compounds. And these carbonyl compounds are highly responsible for the deterioration of the unsaturated fats. So another reaction is the taking place in the meat and meat products, where the amino acid or the protein present in the meat, when it comes into contact with oxygen, that is the oxidation takes place in meat, it leads to formation of ammonia and other organic acids, and this is the elementary reason of spoilage in fresh meat and fish when they are kept without proper storage. So let's move on to the next, and it is the proteolysis. So the proteins present, proteins in the presence of proteinase, the enzyme proteinase, they form peptides, and these peptides, in the presence of enzyme peptidase, they form polypeptides, and these polypeptides are again converted into amino acids. So this is a chain reaction where proteins are converted into individual or amino acids, and these amino acids have different tastes, like the bitter, sweet or sour taste, and which is responsible for off flavor or off taste in the product. And the one other is the action of the enzyme pepsin. So pepsin is the enzyme that is present in every organism, and it is helpful in the normal digestion process for decomposing protein molecules. So this pepsin, generally after the slaughtering of the organism, this pepsin begins to break down the proteins of organs. Thus, the tissues are weakened, and this weakened tissues are highly susceptible to microbial contamination. And one other factor of proteolysis is the action of proteolytic bacteria on any of the food or food component, where it will lead to the deterioration through the same process. And example is foul odor of meat and souring of milk. So we discussed in the spoilage science that protein decomposition may be either due to putrefaction or proteolysis. So it is mentioned here as foul odor of meat and souring of milk. So moving on to the next, it is the putrefaction. Putrefaction is the decay of organic matter by the action of microorganisms, and it leads to foul smell of the product. So putrefaction is a chain of anaerobic reactions where the amino acids are decomposed to a mixture of amines, organic acids, stiff smelling sulfur compounds such as mercaptans and hydrogen sulfide, indole molecules, phenols and ammonia. So all these products, when they are produced due to anaerobic reaction, it causes the off odor to foods. So next factor is the Maillard reaction. Maillard reaction is also called as a non-enzymatic browning, like the caramelization reaction. And this non-enzymatic browning generally leads to the darkening of the product, and when they are not controlled, the darkening, like the intensity of the dark color increases, thus deteriorating the quality. And other issues related to Maillard reaction is reduced solubility of proteins, development of bitter flavors when they are when these reactions happen uncontrollably, and also reduced nutritional availability of certain amino acids such as lysine. So Maillard reaction is a reaction where reducing sugar comes in contact with an amino acid, and lysine is most readily reactive, like the amino acid for this reaction, and there will be nutritional that is there will be decrease in the nutritional availability of lysine as a result of this reaction. And others are the darkening of colors, as I told you, when it is done in the uncontrollable rate. It leads to several it causes several factors that affect the quality of food. And next is the hydrolytic rancidity. So generally when triglycerides comes in contact with water, they break down into glycerol and fatty acid, and this fatty acid may be short chain or long chain, and they cause off flavor. And one fine example is the butyric acid that is created in butter when it comes in contact with water, and it is a smelly compound which indicates the spoilage of butter. So moving on to the next, the light-induced reactions is otherwise called as photosensitized oxidation, and these reactions include the destruction of chlorophyll, resulting in the bleaching of certain vegetables, the discoloration of fresh meats, the destruction of riboflavin in milk, and the oxidation of vitamin C and carotenoid pigments. So that is all about discussing the factors affecting that is the factors responsible for the food spoilage. So we will see every every spoilage, that is the spoilage in meat, cereals, fruits and vegetables in detail in our upcoming sessions. So that's all for today. Stay tuned, know and learn more about food technology. Bye.